So then, question 1, find the derivative of each of the following functions from first principle. First principle. Method is it? Find the derivative of f of x. We say it can be written as f prime of x, or if you are dealing with y, you can write it as y prime, or you can say df dx. The definition of first principle is to use the limit pick h as it goes to 0. H must appear in the function and then divide by the very h. That is, so if a question says use first principle, by writing this, you earn yourself a mark. So our function a f of x is equal to the root of x plus 1. The target here mostly is we want, when we say f prime of x, what we have is the limit as h goes to 0, and then the f of x plus h in the function f, where there is x, we put x plus h. We do nothing to the constants, minus the whole f of x divided by h. Now, if you can look at this function, if you attempt by any chance to substitute where there is h, you take a 0. Everything you have will be undefined because the denominator has a 0. So the reason why in topic 1 we learned assert is that when we get here, we should be able to rationalize the numerator. So we have to rationalize it. You multiply by x plus h plus 1 plus the root of x plus 1. The same here. X plus h plus 1 plus x plus 1. So we still have the limit because I've not done anything. Then multiply, get x plus h plus 1 minus x plus 1 over h, the root of x plus h plus 1 plus the root of x plus 1. So that this just gives us the limit. So we keep writing the limit until we do something that concerns the limit. So far, there is nothing that concerns the limit. So we have x plus h plus 1 minus x minus 1 over h, the root of x plus h plus 1 plus the root of x plus 1. You close. Now you can see that this x and that x, the 1 and the 1, so we remain with on top there is just h. Once h goes to 0, the h is standing up there alone. And h down here multiplying other things. The fact that this h down here is multiplying other things gives us the hope that we can cancel here. So we remain with 1 over the root of x plus 1. So wherever there is h, I can substitute the 0 now. But this is just 1 over 2, the root of x plus 1. This is what we call derivative of this function via first principle. Now, if you look at question 1, the first question should have been this one, or C. But C involves the root again. So you do the same thing that we have done here. You rationalize where need arise. And then D and B, those are bonus questions. When you're resting from rationalizing C, you'll be doing B and D. And this is the question.
Sir,
Okay.
I just want to ask where the H has gone. This one. This one. This H, sir.
Has been cancelled by the one that is down.
Pardon?
It has been cancelled by the one that was down here. This
Okay.
one.
No, I'm not. I'm saying this one in the on the denominator in the square root, sir.
H goes to 0, is it? So it has gone to 0.
Oh yeah. Okay. Okay.
Excuse me, sir. It's so wherever there's going to be an H after the constellation of the two, the one in the denominator and the numerator, it's going to affect every other H that's here, like in the denominator. Like from the constellation of the H from like here. Wait, yeah, the second last equation.
Yes.
Is it going to affect every other H like in the brackets and whatnot?
So you only cancel the one. You only cancel one H that is multiplying. Take out the H that is up. If you only have one H up, whatever
Does
H
that affect-
remains, you substitute a 0 where there is that H.
Why are we substituting, sir?
Because when we say find the limit as x goes to 2 of 3x plus 1, what we do is we substitute where there is x, we put 2 plus 1 for us to get the limit. Is it?
Yes.
Yes. Now, when we fail to get the limit directly, if it was the limit as x goes to 2 of x squared minus 4 over x minus 2, what do we do? If we try to substitute direct here, it will be 0 over 0. So we avoid the 0 in the denominator by factorizing the numerator. So we say the limit as x goes to 2 is going to be x minus 2 multiplied by x plus 2 over x minus 2. And this part and this part will cancel. So we remain in the normal limit as x goes to 2 of x plus 2. And later on substitute to get 4.
I get it, sir. Thank you.
Okay. So this same thing of the limit substituting inside is what we are attempting to do here, except that when we fail, we find the means of getting rid of the h that is making everything undefined. And once we're able to get rid of it, we can substitute the h. Determine with respect to x, a, differentiate with respect to x, y is equal to x power 4 minus 9x power 3 plus 6. So to differentiate this, you can write it as dy dx and differentiate using power rule. And power rule, if you have a function y is equal to x to the power n, power rule says dy dx is going to be n x n minus 1. So keep this. These are things that you must be moving with when you go for dinners. You should not forget this in case these online things finds you at the dinner. So x power 4, our n is 4. So you have 4x power 3 minus 9 by 3, we get 27 x squared. And that becomes our derivative. So this was method 1. Method 2, find that y is a function u divided by v, where u and v are functions of x. You can get the derivative of v and the derivative of y, so that as you get dy dx, it's going to be, so that the dy dx is going to be u prime v plus v prime u. The third method is, so this one is called product rule. We also have what we call quotient rule, the one that involves division. Y is equal to u over v. So you get dy, you get dx is equal to u prime v minus v prime u over v squared. We also have what we call chain rule. Chain rule is where if you have y, u to the power n, you first deduce n and then come back and differentiate u. So if we meet any of these in our questions, we just drop it without saying what we have dropped. Our eyes must be able to see. So B, y is equal to x power 3 multiplied by x minus 2 to the power half. We have emphasized so many times that the root is the same as power half. So whenever we see a root, we write it as power half. And then this is product, so we let u be equal to x power 3, v be equal to x minus 2 to the power half, so that u prime becomes 3x squared, and that v prime becomes half x minus 2 to the power negative half multiplied by 1, because chain rule come into effect here. But a 1 is nice because sometimes it looks as though it has done nothing. So we'll get this. Okay, so now what about dy dx is going to be u prime v plus v prime u. That is, u prime is 3x squared and v is the root of x minus 2 plus u is x power 3 and v is 1 over x minus 2 to the root of x minus 2. So this becomes our
So on that one, you can't go further simplifying it.
there's no need.
All right.
You have polynomials to simplify if you like simplifying. Derivatives, there's not much need of simplifying. You can leave it as scattered as it looks. and present as your answer, because they just said simplify. I mean, they just said differentiate. They never said differentiate and simplify as far as possible. And not C. Let's do D. Y is equal to 3x power 3 minus this guy power 6. So you say, okay, I will let you be the inside 3x power 3 minus x squared. And u prime is going to be 9x squared minus 2x. And then dy dx will automatically be 6 u power 5 multiplied by u prime. This is 6, u is 3x power 3 minus x squared power 5, and u prime is 9x squared minus 2x.
So where is that 5 coming from?
So here we have used chain.
Well, Mr. Kid, I want to ask, what method have you used to solve B and D? Is it the product rule?
B, product rule,
Okay.
method 2. D, method 4, chain rule.
Oh, okay. All right. Thank you, sir.
That's why the 6 here, 6 minus 1 is 5. So that's where the 5 has come from.
All right. Thank you.
That's nice. So that E, F will be represented by G. So G is Y is equal to X plus 1 over X minus 1 to the power 15. So you let U be equal to X plus 1 over X minus 1. And then the derivative of U, we have to use product. I mean, you have to use quotient rule. So you first differentiate the numerator, you get 1, and you multiply by the denominator. And then subtract, differentiate the denominator, you get 1, and multiply by the numerator, and divide by the denominator squared. So if you expand the thing on top, you just get -2 over X minus 1 squared. So when you come here, this is going to be 15 x plus 1 over x minus 1 power 14 multiplied by -2 over x minus 1 squared. So our solution is going to be -30 over x minus 1 squared multiplied by x plus 1 over x minus 1 to the power 14. So the only key thing to know here is knowing how to quickly place on your paper rule number 1, 2, 3, 4. In any assessment, The quiz is going to be
Then,
online.
I have a question.
Mm-hmm. The question can be asked. Okay, you ask when your network is good. So I is y is equal to x plus the root of x, everything in the root. This can be written as x plus x power half.
Hello.
Hello. So you keep timing your network. When it's good, you ask, because we can't hear you.
So continue.
So to differentiate this, you drop the half, keep everything inside as it is to the power negative half, and then go back inside and differentiate. So you get half root of x. And this is the derivative. Question 3. Question 3 is use implicit differentiation to find dy dx of each of the following functions. A, x squared plus y squared plus 8x minus 2y minus 8 is equal to 0. To use implicit, if you are unable to solve for y explicitly, then you can use implicit differentiation. This means that here we've been using explicit differentiation where y is standing alone and then we differentiate it. Now we want to use implicit where y is inside and yet we differentiate it. So we differentiate x squared the same way we've been differentiating with respect to x. We'll differentiate y as if it is x, but once we are done, we remember that it is not x but y. So we'll write dy dx. You differentiate y. Once you are done, you remember, oh, this guy is not actually x. And then you factor out dy dx. So that you have 2y minus 2. And whatever remains, you take the other side. And then quickly divide by whatever is not dy dx. So that dy dx becomes negative 8 minus 2x over 2y minus 2. So we are done. So visible that the 2 can be factored out, but then for what? Nothing. Daniel.
So where there's 2y, do I? Okay, if I can just replace direct with dy over dx without putting a.
Without putting
Y.
you can just do what?
Without putting y, like where you have written like 2x plus
Uh-huh.
2y dy over dx. Is it okay if I can just replace it with dy over dx without putting a y?
It's not okay. You differentiate y squared, just the same way you differentiate x squared. But when you're
All right,
done
thank you.
differentiating y squared, the question is asking for dy dx. But you differentiated y as if it is x. So you write dy dx.
Okay, sir. Thank you.
Mhm.
Excuse me, sir. Excuse me, sir.
Mhm.
How can we solve 2C using first principle?
How can
Solve question using first principle.
how can you solve question 2C? Is it 2C?
Yes, sir.
Network is a bad, So how can we solve question 2C using what?
The first principle.
You just substitute. You just substitute. So if you go back to 2C and you want to use the first principle, look, 2C is y is equal to x squared minus 7x plus 4 over x3 plus 2. So your work here will be, you say the limit, you're looking for y prime, the limit as h equals to 0 of x plus h squared minus 7 x plus h plus 4 over x plus h power 3 plus 2 minus x squared minus 7x plus 4 over x3 plus 2, everything divided by h. And then of course you know that you need to expand, get a common denominator, do the expansion, and you see that the h will remain on top. You can factor out h and cancel the one that will be down. You know, whichever h remains, take 0 where there is that h, and that will be a solution. With good guidance. Question 4. So maybe before you,
Excuse me, sir.
yeah, okay.
On question 3A,
Mhm.
can there be a problem if someone cancels out the factor 2, the common factor 2?
Yeah, there's never a problem.
Alright.
But what happens when you factor it out? Nothing.
All right.
So, Mr. Keith, I was having a challenge with the network. How did you differentiate question 3A? How did the 2y dy dx come from?
The question says use implicit to differentiate this, or implicitly differentiate this. So normally what we have is this. These are normal questions where y is standing alone and you differentiate y with respect to x. But now y is inside some functions. Okay, because what happens is that when you are differentiating a question of this nature, y is equal to 3x squared plus 4. What do? You differentiate y, you get 1, then multiply it by dy dx. and then on the right you have 6x. But because 1 changes nothing, it appears as if it is just dy dx is equal to 6x. Okay, so the very thing that happens here is what we take where y is to the power something. So in this case, y is to the power 2. So we differentiate y, it becomes 2y. Then multiply by dy dx, the same way we multiply 1 by dy dx.
All right, okay. Thank you, sir.
Okay. So what would happen if there was a product at some point? So let's do C. X power 3 plus xy minus x squared y squared is equal to 7. So here what you do is you just differentiate. So you differentiate 3x squared. And then we differentiate this one using product rule. We differentiate x, we get 1 and multiply by y. Plus we differentiate y, we get x, and then write dy dx. In fact, here it should be curve. So when we have
Sorry,
x,
sir,
y,
sir,
mhm.
I joined the session late. How do you differentiate X?
Ask your question again.
How do you differentiate X using the product rule as you mentioned earlier?
So take a sample of these questions that are here. How do you differentiate what? Apart from x, say something else. Pick a question we
The
explain
rest are
for.
different.
How do you differentiate x?
Okay, so I can proceed.
Okay. I'll answer a question when I differentiate one of these parts. So if we want to use product rule, for this case, we let u be x, differentiate it, we get 1. We let v be y, differentiate it, we get 1 multiplied by dy dx. So have u prime v, that is y, v prime u, that is x, dy dx, minus the same thing, we have 2x multiplied by y squared, and then minus 2y x squared dy dx. It will be equal to 0 because the derivative of any constant is 0. Then you factor out dy dx and remain with x minus 2y x squared is equal to 2x y squared minus y minus 3x squared, and divide by x minus 2y x squared, and divide by x minus 2y x squared, so that dy dx is equal to 2x y squared minus y minus 3x squared over x minus 2y x squared. Okay, so this ends question 3, and the 40 minutes is kicking down. So we log out, come back and do question 4, 5, 6. So we should be fast in logging back. Otherwise, you find that we have gone.
So how long is it going to take? Because you have a lecture at 7:30 for mathematics.
Yeah, we are fighting for 7:30. So end at 7:29.